Hi guys, welcome to Step by Step Science tutorial. So today we're in part 17, recommendation system using collaborative filtering. So as we know, the recommendation system is one of the most popular application for machine learning. So today we will use end-to-end Coursera dataset and we will write collaborative filtering in cost function and gradient descent equation from scratch in Jupyter Notebook. So before that, let's start with what is collaborative filtering. So collaborative filtering is widely used for feature learning, and it starts to learn from itself what feature to use. So this might be a bit confusing. So let's take an example. So collaborative filtering is used so that it can learn the feature by itself, right? What does that mean is, so for example, here I have this example I have taken from Andrew Nan Coursera course. So as per this example, you can see this is my movie and this is the rating of the movie. So this movie is denoted by NM, which means my number of movies. And this is the user who have given the rating for this movie from say 0 to 5. They have given the rating. So Love at Last has 5 rating, and this rating is given by Alice. So this is my Y. This is my Y predicted. So Y PII J, which means for user I, for movie J, for user I with for user I having movie J. So this is my Y predicted. So 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 we have this information. So what collaborative filtering does is, by looking at the user and his rating, it it automatically generate a feature. So this x1 y1 is my feature, so it automatically generates the feature, right? So x1 and y1, based on this movie name, it automatically generates feature, whether it's a romance movie or it's a action movie. It automatic collaborative filtering automatically generates feature, right? So here we don't know the rating of whether this movie is a romance movie or is an action movie. So collaborative filtering, even the term collaborative filtering, what it does is it runs the algorithm. It runs the algorithm of a large data set where these users are, if what they are doing is they are effectively collaborating to get better movie rating, right? So, so our task is to find a cost function for this collaborative filtering and to find this feature, this feature, whether my movie is romance or action. So by using collaborative filtering, we usually find this feature and even the parameter theta. So this will be for parameter theta I j. We find this will be our task by using collaborative filtering is to find theta ij and xij. Okay? So these two things we need to find by using collaborative filtering. So the cost function for my collaborative filtering is, so what is cost function? So by using this equation, we can get up the minimum error in the module. How much error we will get in the module is what the cost function tells us. So this is the equation for collaborative filtering. So here x1 to xn is my this is the number of features. So this is this one x1 to xn. So nm is my number of users. nm is my number of movie, and nu is the number of user. So here we have theta. Here Rij. What Rij means? Rij is 1 if user J has rated movie I, right? So here we can say from this example, so for this user, what will be my Rij? Rij will be 1, 1, 1, 0. For 5 it's 1, for 5 it's 1, for 5 it's 1. And for this one, there is no rating, so this we wrote this as 0. Okay, Rij is my Rij is 1 if my user J has rated movie, and Yij is rating given by user J to movie I. So this is what we, the Alice is my Yi, right? So Yi is Alice. So rating given by Alice, rating given by Alice J to movie I, right? User J is my Alice, and movie I is this movie, Love at Last. So our task is to find a cost function for this data set. Okay, so let's look at my data set first. So this is the data set I have used from Andrew and Coursera course. So here we can see Y. If you look at Y, your data set is something like this. So here this matrix means contains rating from 1 to 5 of this much movie on this much user. So this is your movie and this is your user. Which means this, you can say, can take this movie and this user, the number, the rating. So this information is stored in Y variable, right? So Y variable contains your movie, comma, your user. So if you look at Y here, you can see the rating is given here. So this rating is on basis of the movie. For first user, you can say this is for Alice, or and second one is for Bob, and so on. And then we have R. R means if the rating is given, then we have if the rating is given, for example, if rating is 5, then my R will be 1. If rating is not given, then it will be 0. If rating is given, then 1 as 0. Okay. And X, what is X? So right now we know that we have feature because we are calculating cost function. For cost function, everything is given. So in the next part, we will see how this X is being pulled out. So in this video, we will only say writing cost function for recommendation system. So this is the X variable. Say this is my feature here. So X is this much by this one, means number of movies with respect to number of feature. So how much the feature and the multiplication of movies and feature. And theta is for this, theta is the theta parameter, so that we can know once we do the multiplication with feature how much error we get. So this is my parameter. Okay, so this is this information is given, right? And what our goal is, our goal is to write the cost function, this equation, right? This equation is our goal. So here we know theta j x y, theta xk, and our goal is to write this cost function here. Okay, so let's start writing cost function. So I have done the transformation for x. I've done the transformation for x and theta. Now I will write this cost function equation. This equation I will write now. Okay, so let's start. So x and theta is the transformation that we already did. It comes from here. And then So I need to do multiplication of this part and then do subtraction with this part. Okay. So my trade will be multiplication of this x with respect to theta. Okay. Calculate theta dot t, and then theta dot transpose. Then my error will be minus y. So if I integrate this y here, okay, and then need to do whole square, right? So j equals error whole square. So once we do whole square, we need to, it runs from j, so this needs to be the sum and then multiplication of r. So np dot sum times r, and we need to do divide by 1 by 2. 1 by 2 we need to do this division. So this will be 1 by 2 times, then we will, okay. Now we have written this part. Now let's add this two constant theta k and xk. So this is my transformed part, and this is the j that I get from here. Now the sum of lambda divided by 2, then sum of theta k. Okay. Underscore x and b divided by 2 times and dot sum of my theta whole square. Okay, and this is like theta, the x will be lambda by 2. This is x square. You can see theta square and x square. Okay, now find my final like underscore j will be, need to add all the this plus okay, written like j. Okay, so we have done with this part. We have added all these three metrics, and now this is my gradient descent equation. Okay, so we will write this equation now. So first will be my transformation, comma. If this is not making sense to you, if you don't know what is gradient descent, what is cost function, that I would prefer to watch my series from the start. Yeah. So this is my transformation part, theta transpose x, and then do now x underscore value will be equals to error times r because it runs from R. That's why we need to give R and then at the rate theta. So we did this minus and then multiplication with respect to theta. Okay. So theta, this is my theta, right? X squared will be this time, but this will be x. You see, we have error times x, we have error times theta. Next, now we need to combine this two. Let's append. First, and we dot flatten this. Return. So without this part, now we need to do addition of lambda. Okay. So this will be my transform part that we will return from this cost function. We need to add this lambda part. Okay. So like underscore add times, so lambda times x. Okay. So lambda times x plus this grad. So like underscore theta underscore grad will be equals to, then we need to add with respect to xk and with respect to theta k both, right? So here will be theta. Theta plus grad. Okay. So I did mistake here. So we need to return this theta grad and x grad because this is what we are adding. Okay, so let's copy this here. Theta grad we need to add this with theta grad and this with x grad because theta grad and x grad store the previous information, this two information. Okay, and my theta grad was x grad. Now like underscore grad, I will combine all these np dot append. S dot flatten and return this is the equation for cost function. So now I have taken this sample example, for example, for 4 user, 5 movie and 3 feature I have taken, and I have created an object for this recommendation code, and I have pulled this function, this and this both function here, and here we can see my gradient descent, my cost function. This is the value of theta. Now one was without regularization and then with regularization. This is my J, and this is the theta. So that's it for this video. So in next video we will use this equation and we will implement an example so that it would be more clear of what we did. So in this talks we only wrote the cost function. In next part we will look at one example and we will implement recommendation system using collaborative filtering. Hope you like my video. Please subscribe my channel and encourage me to create more videos. Thank you so much.